Okay, so here we are looking to find the volume of a prism. So first of all, you need to think about what a prism is. Well, a prism is just a shape that has a face repeated all the way through it. So we're looking at different three-dimensional shapes that have this kind of same repeated shape all the way through. So a couple of picture examples there. We've got a square-based prism, a triangular-based prism, a hexagonal-based prism. So the square-based prism is just a cuboid. Okay, we've seen them before. Triangular-based prism that looks just like a kind of Toblerone shape, and they tend to be our kind of common go-to examples when we're looking at this. Okay, so essentially what we should be able to do is we should be able to cut through that triangular-based prism so that there is still that same face that we see. And so if we imagine taking our Toblerone and we split it in half to share it with someone, once we've done that, at either end we still see that triangle shape. And if we take our half and we split it in half again, share it with someone else, we're still just seeing that triangle shape repeated all the way through. And that's what it is we're looking for when we want to find a prism. So in order to find the volume of the prism, we are going to find the area of that repeated shape and multiply it by the height. Okay, and that is the formula in the way that we get it on the formula sheet. Okay, so A here is the area of this repeated shape. So for the square-based prism, it would be the area of the square. The triangular-based prism, the area of the triangle. The hexagonal-based prism, the area of the hexagon. Okay, if it is a more complicated shape, then we'll find that we just get given that area. But there are some that we need to be able to work out. So we will be expected to work out the area if it is a rectangle or a triangle. So if it's one of those kind of shapes, then we will have to work that bit out first. Otherwise, they'll just give us it. So, moving on to an example. Okay, I am looking at some kind of prismy shape here, so it looks like it's kind of standing up T that's sticking out the way. And so I've got the volume equal to the area times height. So there's some clues here in the question as to what it is I'm looking to do. It tells me that the area on the top is 24 square millimeters, and that's the way that we're going to be slicing through. We're going to be slicing through this horizontally this time. Okay, so the area that I've got is 24 multiplied by the height of the shape, which is 2, and 24 times 2 is 48. It's a volume, so we're looking for cubic millimeters this time. Okay, so all I've got to do is match the numbers up into my formula. Now, we use the term height, but really what we're looking for is we're looking for the other dimension. And so sometimes we can do like what we've done here in the second example. Let's move it in that too. And this time it's lying down flat. Okay, and so this time we're going to be slicing through vertically, which means that number there, that 20, is actually going to be my height because the shape that is getting repeated through it would be that triangular shape there on the front. So in the same way that keyboard, same thing on the top. When I was looking for my shape, it was that bit there that was getting repeated. I need to find the area of this triangle down the bottom. So the first thing I need to do is find the area of the triangle. So we've got a half base times height. So half of 8 times 7. So the base of my triangle is 8, the height of it is 7. Crunch my numbers, I end up getting 28. Which means when I do my volume, which was my area times the height of the prism, I've got 28 times 20, which is 560. My units this time were in centimetres, so it becomes cubic centimetres. And this is the thing that's going to cause us some mistakes. It's going to be the bit that causes us to trip up. Okay, is that both my formulas refer to h, height, but depending on what part it is we're looking at, it's actually referencing a different part of the shape. Okay, so here I'm looking for just the height of the triangle, whereas in the volume I'm looking for the height of the shape. And what we've done is we've laid our shape down, so the height now in my shape and my prism actually looks like it's the depth. Okay, so we need to be careful that we don't get those things mixed up.